Hi students, welcome to the last part of the non-parametric test. So, in this session we are going to discuss about application of Kruskal-Wallis H test and Friedman rank test. So, previously we have discussed about the procedures of Kruskal-Wallis test and Friedman rank test. In this session we are going to do the problem practically how to solve using Kruskal-Wallis test and Friedman rank test. First we will solve a problem in Kruskal-Wallis test. An example problem, let us as production manager you want to see if 3 filling machines have different filling times. You assign 15 similar trained and experienced workers, 5 per machine to the machines at the 0.05 level of significance, that is 5% level of significance. Is there a difference in the distribution of filling times? And from the data we can see like machine 1, machine 2 and machine 3, and each machine have 5 data sets. Okay. So, now we are going to compare between 3 different machines, which from the problem we can easily understand, like we are going to do the comparison between 3 different machines and we are going to conclude like whether all the 3 different machines do the same process or not. So, first thing we have to frame the null hypothesis. The alternative hypothesis, null hypothesis is nothing but identical distribution, and the alternative hypothesis is nothing but at least 2 different groups are different, and alpha equal to 0.05 and degrees of freedom, here we have 3 groups, that is p minus 1, that is 3 minus 1 equal to 2, and critical values. Now, from this graph we can easily understand we are going to consider alpha equal to 0.05 and the value belongs to 5.991 using the chi-square table. Now, we are going to do the calculation. So, solution for the problem. So, this is left side shows the raw data machine 1, machine 2 and machine 3, and we can see in the right side we have the ranks. So, first we are going to give the rank to the lowest value. The lowest value is nothing but 19.75 and the second lowest value is nothing but 20 and the third lowest value is nothing but 20.4. Like this we have to continue the process and give rank to each observation. So, now we can see at last we have given the rank to all the 3 machines. So, from starting from 1 and we have ended with the 15 ranking, and we have to proceed further to calculate the total of rank for each group. Now, we can see from the first column like machine 1 we have the total rank as 65 belongs to the first group and 38 as machine 2, that is the total of rank belongs to the machine 2, and in machine 3 the total rank is 17. Now, we can calculate the test statistics value. So, Kruskal-Wallis test we know the formula as 12 divided by n into n plus 1 summation r j square divided by n j minus 3 into n plus 1. So, now we already know like the sample size is 15. So, 12 divided by 15 into 16 and the r j represent nothing but rank of the each group. We already calculate the first group is 65 and second group is 38 and third group is 17 divided by all the group have only 5 observation. So, we are going to square it minus 3 into we already know like n is equal to 15. So, it is 16. So, by solving this at last we have calculated the value as 11.58. Now, we are going to do the interpretation. We know that the null hypothesis is nothing but identical distribution and the alternative hypothesis nothing but at least 2 groups are different, and level of significance nothing but alpha equal to 0.05 and degrees of freedom we already know like we have already discussed, that is 2. Now, the decision will be like we are going to reject at alpha equal to 0.05. The reason behind is like the test statistics is h equal to 11.58 and we have the calculated value as 5.991. So, which is greater. So, we are going to reject it at 5% level of significance. At last we are going to conclude that there is evidence that population distributions are different, that is 3 different machines perform in 3 different ways. Next, we can discuss about an example problem in Friedman rank test. Suppose we are interested in knowing the effect of stress on the ability to solve the problem. We are going to consider 12 subjects are recruited and asked to solve the problem under each of 3 conditions after a pre-test period of no stress and mild stress or moderate stress. So, we have 3 different kind of time, that is no stress, mild stress and moderate stress. We counterbalance these three conditions to ensure that the order of the presentation does not affect our result and the problems are graded on a 100-point scale. So, let us see what the problem gives. So, we have 12 subjects and we have 3 different time, that is no stress, mild stress and moderate stress, that is the 3 different kind of columns. So, in the next table we are going to give the hypothetical result are presented or accompanied by their ranks. Next we see how to rank the each group. So, now we can understand from this table for subject 1 we have ranked row wise. Row wise means we will take the rank of 3 observations, which is lowest one, the 50. So, that will take rank 1 and second lowest is 60, that will take rank 2 and the third one is 65, that will take rank 3. So, what is the difference between the Kruskal-Wallis and Friedman rank test calculation? The calculation wise in Kruskal-Wallis test we will give the rank by the column wise. In Friedman rank test we will do the rank wise in the row. So, that is the difference. So, you can easily understand for the 12 subject we are giving rank by the row wise. For the second subject we can see which is the lowest one, this 70. So, that will take rank 1 and second lowest is 80, that will take rank 2 and the third lowest is 85, that will take rank 3. So, from this we can easily understand his or her scores of 65, that is no stress, 60 after mild stress and 50 after moderate stress correspond to the rank of 3, 2 and 1 respectively. Now, we can see about the null hypothesis. So, the null hypothesis is nothing but that the score under each condition are from identical population. If this were true, the ranking within each condition could be in random wise and any difference across condition could be due to the chance. Next, we will see about the calculation of the chi-square. We know that the chi-square f is nothing but the test statistics belongs to Friedman rank test. The formula is 12 into summation r j square divided by n k into k plus 1 minus 3 into n into k plus 1. Let us substitute the values. So, chi-square f equal to 12 into the r j square nothing but the rank of the sum of rank of the first group, second group and third group, that is 28 square plus 27 square plus 17 square and we have 12 observation, that is n. So, 12 into and we have 3 groups, that is 3 plus 1 4. So, by substituting all the values we are calculating the chi-square f. At last we will get the chi-square f the value as 6.17. This is nothing but your calculated value using the Friedman test statistics. Next, we will see about the interpretation. To evaluate the outcome at alpha, nothing but the level of significance. Here we are going to consider as 5%. Look at the critical table value for degrees of freedom k minus 1, that is 2. So, the critical value is nothing but 5.99. So, our calculated value is 6.17, which is we done earlier, exits this. So, we reject the null hypothesis and conclude that ability to solve problem is affected by the stress. The stress we have 3 groups, that is no stress, mild stress and moderate stress. So, in this session so far we have discussed about Kruskal-Wallis test, how to proceed with the Kruskal-Wallis test, and we have discussed about Friedman rank test and the procedures involved in Friedman rank test, and at last we have discussed about the solving the problem using Kruskal-Wallis test and Friedman rank test. So, from the last 3 lessons we can easily understand we have covered everything about the non-parametric test. So, first lesson we have discussed about what is the difference between non-parametric test and parametric test and the real application of the non-parametric test, and in second lesson we have discussed about the sign test for one sample and Wilcoxon sign rank test, and in the third lesson we have discussed about the magnitude test and the other non-parametric test. So, from these 4 lessons, if we go through it, we can easily understand about the overall view about non-parametric test. In the upcoming session, we will be discussing about the brief introduction about SPSS. Thank you.